In this video, I'm going to talk about increasing and decreasing functions and the first derivative test. Okay, we will use derivative to find out the interval for a function where it is increasing and decreasing. Okay, so on this figure, this is the graph of the function fx, right? Where is the function increasing? This is increasing, right? This is this piece. On this piece it is increasing. You see that? Increasing. On this piece it is decreasing, and on this piece it is increasing, right? So you see that this point, the tangent is parallel to the x-axis. You see that? At this point, if you draw the tangent, at this point, if you draw the tangent, it is parallel to x-axis. So meaning the first derivative is 0 here. At this point, at 3 and at 6, the first derivative is 0. And on the first derivative is the slope, right? So slope is 0. Slope of this tangent is 0. That's why it is parallel to x-axis. Slope of the tangent at 6 is also 0. And because it is parallel to x-axis. On the left of 3, between 0 and 3, the graph is increasing, right? Meaning the slope is positive. So the slope is positive between 0 and 3. And between 3 and 6, the graph is decreasing. So the slope is negative. Meaning the first derivative is positive here. The first derivative is negative here. You see that? Because the slope is the first derivative. And between 6 and 10, the graph is still again increasing, right? So increasing graph means the slope must be positive, meaning the derivative must be positive there. You see that? So how can you write that then? So it is f prime is positive here, is f prime is negative here, f prime is positive again. So f prime is positive. Okay. So this is how we use the derivative or the slope to find out where the function is increasing and decreasing. So how do we know the critical points? Critical points are the one where either the slope is 0 or the derivative is 0 or derivative is undefined, right? So at 3, at the point 3, at this point, when x is 3, the slope is 0 here, right? That is the critical point. So you write x equals to 3 is the one. What is the another one? X equals to 6 as well. So 3 and 6 are the critical points. There are no points where the first derivative is undefined because there is no sharp corner, there is no cusp. Okay. So what is the increasing interval? When you write the increasing interval, you write the x values. Okay. Increasing interval is between 0 and 3. So you can write the positive, the bracket or the parenthesis. So let's write down 0 to 3. Or if you write 0 to 3 in the parenthesis, that's also fine. And what is there any other increasing interval? Yes, there is. And if you have 2, you write u, or sometimes you denote by, you separate by comma, or you combine by u. U is the union, okay? You can write 6 to 10. If the question asks find an open interval, then you write the open interval there, okay? Just the parenthesis there. How about the decreasing interval? Decreasing interval is between 3 and 6. 3 and 6. You can write open interval or closed interval. It depends on how the question is asking, okay? So there are 2 increasing interval here. There is 1 decreasing interval here, okay? Let's write on the note. So if the first derivative is positive for all x in AB, this is open interval, right? Then f is increasing in the closed interval AB. Okay. If the first derivative is positive, then f is increasing. The function is increasing because it is positive up to 3, right? 0 to 3, open interval 3. Because at 3 it is 0. So from 0 to 3, open interval 3, open at 3, it is increasing. That the first derivative is positive, so you can say that f is increasing on AB. Similarly, if the first derivative is if less than 0 is negative for all x in AB, open AB, then f is decreasing in that AB. You can write, or you can write 3, 6. This is also fine, okay, on AB. But if f prime of x is equals to 0, then f is constant. So here f is constant at one point, right? If there are some places, right, like f is not neither increasing nor decreasing, or if f prime is 0 for many points, you write an interval there. So we call it is constant or neither increasing nor decreasing, right? Neither increasing nor decreasing. So that's the when the first derivative is 0. So there are steps to find out the increasing and decreasing intervals if graphs are not given. If the graph is given, you can look at the graph and then see where it is increasing and where it is decreasing. But if the graph is not given, we will not draw the graph. We will use the derivative to find out the increasing and decreasing interval. Okay, these are the steps. First, find f prime of x. For a given function, you find out f prime of x and find the critical numbers. How do you find out the critical numbers? What you do is you do f prime equals to 0 and find x. This is one. The other is find x where f prime not defined, right? Not defined. So you find out those points of x where f prime is 0 or f prime not defined. Find out those values of x are called the critical numbers. Okay. And after you find out the critical numbers, you draw a number line and mark those critical numbers. Okay. Use test point to find signs of the first derivative at each piece in that number line. Okay. Determine increasing and decreasing interval based on that. Okay. So once you do an example, it will be very clear. Let us follow these steps. First, find out f prime. What is f prime? F prime is 2x minus 2. Okay. Set f prime equals to 0. So f prime equals to 0 implies 2x minus 2 equals to 0. Now solve it. How do I solve this? You just add 2, right? So what do you get? You get 2x equals to 2. 2x equals to 2. Divide by 2. What do you get? You get x equals to 1. So this is the only critical number, right? Because there is no x values where f prime is not defined, because there is no x in the denominator. So we don't have to worry about undefined f prime. Okay, x equals to 1 is the critical number. So after you find out the critical number, what would you do is basically you draw a number line. Okay, draw a number line and mark that critical number. There is just one critical number, that is 1. Okay, I mark that. So what do I do after that is, now I take a test point and then use the test point to find out the sign of f prime. Okay, so what do I do is I will pick a test point or test value. So I want to make a small table there, because this is the critical number, right? So there is one piece on the left side, one piece on the right side. What piece is on the left side? Let me write down that interval. Okay, and then I want to write test value, test point, test value, and then I want to write sign of f prime, f prime. Okay, and then we do conclusion. Okay, let us make a table that will be easier for you guys. So what are the interval? Interval means basically the piece, right? What is the left piece? It is negative infinity to 1, open interval. And then another piece is right piece, 1 through infinity. That is also open. Why did I do open? Because at 1, the f prime is 0 at x equals to 1. Okay, so that is basically the critical number. So we will look at the piece excluding those critical numbers. Okay, we exclude those critical numbers. That's why I have the open interval. Now I want to pick a test value here. What test value you want to pick? I want to pick, let's say 0, because 0 lies left of 1, right? And on the right side I want to pick test value 2, because 2 is right of 1. You see that? So let's do that. So I want to pick 0 and then 2 as the test value. Now sign of f prime. What is f prime? F prime is 2x minus 2, right? So you can see that f prime equals to 2x minus 2. Now what you do, you plug in that 0 on that f prime and then find out the sign, and plug in 2 on the f prime and find out the sign. When you plug in 0, what do you get? 2 times 0 is 0 minus 2 is negative 2, right? Negative means sign of f prime is negative. You see that? You can write negative, 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 negative. Because on this test point, it is negative means everywhere it will be negative. Okay. Now let's pick another test point 2 and plug it in f prime. So 2 times 2 is 4 minus 2 is positive 2, right? So that will be positive there. Or you can write plus, 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 plus like that. You see that? Now conclusion. If it is negative, it is decreasing. Because f prime is negative means decreasing. And f prime is positive means increasing. So how do I write the final answer then? So the final answer look like this. So increasing in on the interval negative infinity to 1. You see that? Or you can see here or in the table. So on the left to 1, it is increasing. Oh, by the way, that's not right because it is decreasing, right? So decreasing on the interval negative infinity to 1 and then increasing on the interval on the right of 1, right? So 1 through infinity. This is the final answer. This is how we write. You understand that? Okay. So let us do another example. Find the open interval on which y equals to x root under 16 minus x square is increasing or decreasing, right? So because see, you know the domain of this function is not all real numbers, right? Because there is a root under, so there are only certain values of x that makes the root under the quantity under the root positive. Okay, the other values of x will give you negative. So let's find out the domain. What is the domain first? Okay, so here the domain is basically domain is, see, if you solve this inside the root, you will get x equals to positive 4 and negative 4. So anything outside the positive 4 and negative 4 will make this number bigger than 16, and that will give you negative number on the root. So the domain is, see here, domain is negative 4 to positive 4, right? So when you find out the critical numbers, you will list only those critical numbers that lies between negative 4 and positive 4. Okay, you will list only those. All right. So, and when you draw the number line, you will do between negative 4 and positive 4 as well. Only between negative 4 and positive 4. Outside, the function is not defined. That's why. Okay, so what we do next is we find out that we follow that step. Find out f prime of x. What is f prime of x? It is the product rule, right? So it is kind of, you can see that it is like f times g, right? So what is the derivative of f times g? It is f prime is 1 times g is 16 minus x squared. You see that? And then plus f prime. So f times g prime, right? It is f prime times g plus f times g prime. Meaning f is x times g prime. What is g? G is 16 minus x squared to the 1/2. And you are finding the prime of this, right? Prime, the derivative of that. You see? So when you find out the derivative, you can take this as u to the 1/2, right? U to the 1/2. So what is the derivative of u to the 1/2? Let me write down that. So 1 times 16 minus x squared is 16 minus x squared, right? And then plus x times. What is the derivative of u to the u prime? U prime is nu n minus 1, right? So, sorry, u to the 1/2 prime. So it will be 1/2 n, u is 16 minus x squared, and then n minus 1, 1/2 minus 1 times u prime. What is u prime? The u is 16 minus x squared, so prime of that is 0 minus 2x will be negative 2x. That's what you get. You see that? And this 2 divided by 2 will be just 1. Okay. So what is left is, let me write down that, root under 16 minus x squared. And there is positive x times negative x will be minus x squared times, what is that? 16 minus x squared to the negative 1/2, right? I want to move this to the bottom to make it positive 1/2. So 16 minus x squared minus x squared over root under 16 minus x squared. You see that? Why did I do that? Because this will go to the denominator with positive 1/2 in the exponent. Anything with positive 1/2 in the exponent is the root. Okay. Now I want to combine these two. How do I combine? This is just basically, there is 1 in the denominator, right? So how to combine that is basically root under 16 minus x square. Okay, and then you do the cross multiplication, right? So it is this times that will be 16 minus x square root times root 16 minus x square, just 16 minus x square minus x square times 1 is x square. So basically you got 16 minus 2x square, right? 2x square over root under 16 minus x square. So I want to find out the critical points. To find out the critical points, you set that f prime of x equals to 0, and then find out where f prime of x is undefined. F prime of x is undefined if x equals to plus 4 and minus 4, right? So you can see the critical numbers are, to find critical numbers, you do f prime equals to 0 implies 16 minus 2x square over 16 minus x square equals to 0. Okay, you multiply both sides by 16 minus x square, root 16 minus x square. So let me write down this a little bit further away. So what you do here is you are basically multiplying by 16 minus x square times 16 minus x square times 16 minus x square. So this whole thing will be 0, right? This will be 0. That and that will cancel out. You see that? So what is left is 16 minus 2x square equals to 0. Now add 2x square on both sides. What do you get? Plus 2x square plus 2x square implies 16 equals to 2x square, right? So what do you get? Divide by 2. You see that? Let's divide by 2. Divide by 2. What do you get? This implies x square equals to 8. So what is the value of x? You take the root on both sides. You get x equals to plus and minus root 8. Do you know how to write 8 in the product form? It is basically plus minus. You can write 2 times 2 times 2, right? But for these two under the root, you can take 1, 2 out. So it will be plus minus 2 square root of 2. Is this critical point lies inside between negative 4 and positive 4? The answer is yes, because root 2 means 1.41 times 2 will be 3 point something or 2 point something. So it falls plus minus, that will fall between negative 4 and positive 4. Okay. So what are the other critical numbers? So at x equals to negative 4 and positive 4, f prime is not defined, right? So the critical numbers are plus minus 2 root 2 and then plus minus 4. These are the critical numbers. You see that? So it was long work. I mean the more work for the critical to find out the critical numbers, right? That happens sometimes. So what we do next is we draw a line and mark those values. When you draw the line though, you don't have to draw outside negative 4 and positive 4 because the domain is negative 4 and positive 4 only, right? So this is one critical number, right? Let me use different color for that. So this is one critical number. Another critical number is negative 2 root 2. Another critical number is positive 2 root 2. And the another critical number is 4, right? Let me write down those. Negative 4, negative 2 root 2, positive 2 root 2, and then positive 4. So what is your f prime? F prime is that quantity, right? So let me write down f prime here. I want to write f prime equals to 16 minus 2x square divided by root under 16 minus x square. Okay, so I don't have space to make a table, but what I want to do is I want to pick a test point. Pick a test point here. What is negative 2 root 2? How much is that value? Let me find out the number for negative 2 times root 2 is basically 2 times square root of 2. It's basically 2.82. So basically this value is negative 2.82. Negative 2.82. This is positive 2.82. I want to know how much is that number definitively so that I can pick a test point in the middle there, right? So I want to pick a test point. So let's pick a test point negative 3. And between negative 2 root 2 and 2 root 2, I want to pick a test point as 0. You can pick any number, but pick a whole number so that it will be easy to plug in f prime, right? Because we will have to pick a test point, test value, and then plug it into the f prime and find the sign of f prime, right? In that way, you will decide decreasing and increasing interval. And on this one, I want to pick positive 3. Okay? Let's plug in the test point in the f prime and then look at the sign. See that? Let me plug in the test point there. If I plug in the test point negative 3, what do I get? It will be 16 minus, you can use calculator or just do by hand, it is not bad. 16 minus 2 times negative 3 square. Negative 3 square will be positive 9, right? Positive 9 times 2 will be 18. So 16 minus 18, you will get negative sign on the top. On the bottom, 16 minus 3 square is 9. 16 minus 9, negative 3 square of negative 3 is positive 9. So 16 minus 9 is 7. So you will get a positive sign on the bottom and negative sign on the top. So negative over positive will be negative. So it will be minus, 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 minus. In this piece, it will be negative. So it is decreasing piece. Okay. How about here? Plug in 0. 16 minus 2 times 0 is 16 minus 0 is 16 over 16 minus 0 is root 16. So it is positive over positive. So it will be plus, 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 plus. Okay. Now how about here on this piece? Plug in 3 again. So 16 minus 2 times 3 square is 9. So 16 minus 18, right? Will be negative and this will be positive. 16 minus 9 will be positive. So negative over positive is again negative. So what is your final answer? Let me write down the final answer here because I am running out of space. So final answer I want to write down here. Okay. So what is the increasing interval? Increasing is the interval where it is positive, and the question is asking the open interval, right? So I would write negative 2 root 2 comma positive 2 root 2, right? This is where it is increasing. And what is the decreasing interval? Decreasing will be the piece where it has negative sign. So negative 4 through negative 2 root 2, and then union, or you can separate by comma. Okay, union and 2 root 2 through 4, 2 root 2 through 4 open. So you can separate that by comma, or you can write union. So both of them should work. It depends on what the online homework asks. Okay, I'm okay with both of those. All right. So this is the decreasing interval because it has the negative sign. So you can make a table like this, or you can just work on the horizontal line and find the sign and then see that. Okay, you can see where it is increasing and decreasing depending on the sign. So if the sign of f prime is positive, then it is increasing. If the sign of f prime is negative, then it is decreasing. For the positive sign, it is increasing. For the negative sign, it is decreasing. Okay, so we will see a couple more examples. Okay, let us look at this example here. Okay, so here fx equals to x plus 2 cosine x, and you want to find out where it is increasing or decreasing. Well, you don't have to look outside this. It says you need to just look inside this interval between 0 and 2 pi. Okay, so let's follow the steps. We find out f prime of x is how much? It is 1 minus 2 sine x, right? Since this function is defined everywhere, meaning that f prime of x is defined everywhere, and definitely for this interval it is defined, so you don't have to worry about where the first derivative does not exist. You don't have to look at that side. Okay, so only you need to look at where f prime of x is 0. So set f prime of x equals to 0 implies 1 minus 2 sine x equals to 0, right? So how do I solve this for x? You subtract, you add 2 sine x on both sides. What do you get? You get basically 1 equals to, or you can say 2 sine x equals to 1, right? 2 sine x equals to 1. Divide by 2. You get sine x equals to 1/2, right? So you take the arc sine. So you will get arc sine, and then sine x, right? Equals to arc sine 1/2 half. You see that? So what are the values of sine? That gives you 1/2. You'll get that arc sine and sine will cancel out, right? That basically cancel out. So what is left is x equals to, what is the value of arc sine? 1/2. Sine is positive in first and second quadrant, right? So meaning that you will have to look the value in first and second quadrant only. So you will get pi over 6. You see that? That's one value. And then the other value will be pi minus pi over 6, right? How much is that? So that value is basically pi minus pi over 6 will be 5 pi over 6, right? 5 pi over 6. So these are the critical numbers. Now what you do is you want to, after you find out the critical numbers, let me write down critical numbers. These are the critical numbers. Now you draw the line, right? And then mark those critical numbers. So there is somewhere there is pi over 6 and somewhere there is 5 pi over 6, right? Now what we do next is we pick a test point and then find out the sign of those, okay? Pick a test point here, pick another test point here, and pick another test point here. What test point you want to pick? I want to pick 0 here. Close to, yes, I want to pick 0, that's fine. Let's pick a test point 0. And between pi over 6 and 5 pi over 6, I want to take, so let's take the average. What is the average of pi over 6 and 5 pi over 6? It will be 5 pi plus pi is 6 pi over 6. Let's pick pi. Okay. And let us pick 5 pi over 6 bigger than, oh, by the way, so pi over 6 plus pi over 6 over 2, 12 pi over 2. So pi over 2 lies between pi over 6 and 5 pi over 6, not pi. So pi goes here, right? Because what is the number bigger than 5 pi over 6? That will be 6 pi over 6, right? So 6 pi over 6 will be pi. So I found the average of those two in the middle just to find out a middle number that lies between pi over 6 and 5 over 6. So this plus this divided by 2 will give you pi over 2. Okay, guys? Okay, so let's plug into the f prime. What is f prime? F prime is equals to 1 minus 2 sine x. 1 minus 2 sine x. So I'll plug in x equals to 0, x equals to pi over 2, x equals to pi. And then I will check the sign there. You see that? So can you tell me what is the, if you plug in 0, what do you get here? 1 minus 2 sine 0. Sine 0 is 0, right? So 1 minus 2 times 0 is 1, just 1. So 1 is positive. So you write positive sign there. That's positive. Now let's plug in pi half. 1 minus 2 sine pi half is 1. So 2 times 1, right? Because sine pi half is 1. So 1 minus 2 times 1 is 1 minus 2. It is 1 minus 2 is negative 1, right? So it is negative. So you don't worry about how much do you get, you just worry about the sign. What sign do you get is the important, then the value. Now let's plug in pi. So 1 minus 2 sine pi. Sine pi is 0, right? So 1 minus 2 times 0 is just 1 minus 0, right? So 1 minus 0 is just 1, so it is positive. So since you need to look at between 0 and 2 pi, okay, you need to find out a number that lies between 0 and 2 pi. So maybe 0 is not a right or the perfect test number. So I want to pick a test number. Let's say, what is the number between 0 and 2 pi? You can take 0 and 2 pi, because you don't have to look outside, right? You don't have to look outside 2 pi and I mean bigger than 2 pi and less than 0. You don't have to look at that. So 0 does not fall there, right? So 0 may not be a very good perfect value, but you will get the same answer, no worries. But 0 is not a perfect value to take as a test number, okay? So what I want to do is, what is the number bigger than 0 and less than pi over 6? You can take pi over 7. Pi over 7 as a test number, okay? If you put here 1 minus 2 sine pi over 7, so how much do you get? Let me try that value. So 1 minus 2 times sine pi over 7, right? So let me do sine and then pi over 7. I got 0.13, positive 0.13. So it is still positive. it is still positive. So no worries about these positive signs there. No worry about that part. Okay, so basically you should pick 0 as one of the boundary there, so it is not a test point. So I took a test point as pi over 7 and I got 0.13, so it is positive. So increasing in the interval 0 to pi over 6 and then comma 5 pi over 6 to 2 pi. You go up to 2 pi, right? Because see, it says 0 to 2 pi. So the left bound is 0, the right bound is 2 pi. So left bound is 0. 0 there, right? And I pick a test point. This should be blue color. So I pick a test point that is, let me do that blue color so that it will be easy for you guys. So let me make it basically blue color so that you will know that blue color is basically the test point. Okay, so this is pi over 7. I terminated at 0 and 2 pi because the question has given that. And when it is decreasing, let me write down the decreasing interval. Decreasing is between pi over 6 to 5 pi over 6. That is the decreasing interval. Okay, because that has the negative sign. Between pi over 6 to 5 pi over 6, it has a negative sign. That's right. Okay, so once you plug in a test point, and if you get a positive sign when you plug in that test point, then that piece, the whole piece will have positive sign. If you get a negative sign for that test point, the whole piece will have the negative sign. Okay, so you should be careful on that. Okay.